Good afternoon, grade 9s. It's Mr. Halley here. We're going to look at some revision of algebraic products that we did earlier this year. And I hope as I go through this today, a lot of this you are well aware of, but hopefully it might help some of you to clarify things. Please, you can download this worksheet in the description below to work along with me. And if you follow the other link in the description, they will have a worksheet where you can practice a lot more of these. Alright, let's get started. So what do we talk about when we're talking about a product in algebra? Well, products mean to multiply. So if we look at our very first one here, where is this multiplication? Well, we've got this pair of brackets multiplied by that pair of brackets. When we write brackets next to each other, we know that we're implying we're going to multiply. And what are we multiplying? Well, inside the brackets, here we have two terms. And inside this pair of brackets as well, we also have two terms. So when we multiply two terms by two terms, we would expect to get four terms as an answer. Where do those four terms come from? Well, there's a couple of ways we can do this, but the way that I've always enjoyed is what we remember as FOIL. Now, FOIL is not a mathematical idea. FOIL is just an easy way for us to remember what do we need to multiply with what. So what does this F stand for? F stands for multiplying the first term by the first term. And when we multiply x by x, we realize in algebra that that is x squared. O stands for the outer terms of the brackets, on the edges of the brackets. So we have an x multiplied by -2. When we multiply x by -2, we write that as -2 times x. We write the number in front of the letter. I stands for our inner terms, so -5 times positive x will give us -5x. And L stands for our last term, -5 times our last term in the bracket, -2. A negative times a negative is positive. 5 times 2 is 10. The most important thing to remember when we're doing FOIL is that we're multiplying the terms. So make sure you multiply those terms. So therefore, what does this actually equal? Our answers here. We have x squared as our first term. -2x is our second term. -5x is our third term. And our last term is +10. Notice that when we multiplied two terms by two terms, we got four terms. Well, if we look at that, that's a perfectly good answer, but we've also learned in algebra that now that I've done my multiplication, I look, is there anything that I can add and subtract? Those two terms we can add and subtract because those are like terms. The letters are the same with the same exponents. So we keep x squared. And then we say -2, and I'm going to subtract another 5. That gives me -7x's. And then I'm left with 10 constants. And that expression is the product. That is the answer to the original question of FOIL. Now, let's look at the next one here. Compare question number 2 with question number 1. A lot of those letters are the same. I've got an x and an x. And I've got a -5 and I've got a -2. So this to me is looking very similar to question 1. However, we're missing these brackets. There are no brackets around these terms. We can't just go and put them in. That wasn't in the original expression. So what are we asked to do here? Where is the multiplication? Well, we can see that when we write a number next to a bracket, that means multiplication. So we want to multiply 5 by x plus 2. That is what we learned in grade 8 as distribution. But you also learned in grade 8 that we don't just say 5 times x and 5 times 2. We say -5 times x and -5 times 2. What does this symbol represent to us? Well, this is a really tricky symbol because this minus symbol can mean two things. In the original expression, this means to subtract. But I've just been talking about it as a negative. And this is one of the things that makes algebra quite tricky. What's the operation? The reason we have to do the multiplication before subtraction is because of BODMAS. And we couldn't subtract x and 5 anyway. But this is the thing that tells us we need to multiply this 5 by. But why are we multiplying by -5? Well, in fact, you'll see this many times over, that in this case we actually read it more like this. We read the -5 as being multiplied by +2. We know that if we add a negative, well, it's going to be the same as subtracting a positive. So in fact, our focus here is just on multiplying the -5 times x, and then we're going to multiply negative by a positive, which will give us negative, and 5 times 2 is 10. So we've done the multiplication that was requested of us. What's left to do? Addition and subtraction. And now we want to read this minus symbol now as subtraction, because we are saying I've got 1x and I'm taking 5 of them away. I've got -4x minus 10. And that is the simplified version of that original expression. Tricky, huh? Alright, let's look at the next one. Compare question 3 to question 2. Gosh, I've got really boring numbers here. I keep using 5s and 2s and negatives and positives, but I'm trying to draw your attention to how critical it is the order we write things in, where the brackets are. So if we look at this one here, all I've done is change the order of the subtraction. Instead of x minus 5, 5 minus x. Is that going to make a difference to our answer? Well, we know that when we subtract, order is very important. Let's focus here. What's the operation we've been asked to perform? Again, this minus symbol can be read as subtraction or as multiplication. We're going to read it as 5 add -x times x plus 2. So we can deal with the negative being multiplied by both terms and x being multiplied by both terms all in one go. So we're going to keep our 5 because that's involving addition and subtraction, and we're going to do our multiplication. And a -x multiplied by +x is -x squared. Then we look and we say -x multiplied by a positive, well, this gives me a negative x times 2, well, that's the same as 2 times x. Now if we look, do we have any like terms? No, we do not have like terms here. I've got a constant, I've got x's, and then I've got x squared here. So in fact, we can't go further with this expression. We have to leave it just like this. You could write it in descending powers of x, but that's not necessary here. So compare your answer to 3 and 2. We get totally different answers by changing the order of 5 minus x and x minus 5. Okay, let's look at question 4 here. In question 4, we got to look now, what is the operation? Is there multiplication here? Now some people will read this minus here as a negative times, and that absolutely works. You can think about a -1 there, and we're going to multiply -1 by x and -1 by +2, and that will give us absolutely the right answer. I'm going to suggest that this here means subtraction to us. We're going to subtract each one of these terms. So in fact, we don't really have multiplication here. We've got the subtraction of 2 terms. So we're going to keep our x and our -5, and then we're going to subtract an x. Now, this next time is we're going to subtract a -2. Now, some of you would have immediately gone, well, isn't that just +2? Absolutely it is. Well done. We realize that when we subtract a negative, it's going to be the same as adding 2. So we've got x minus 5 minus x, and then we're going to add 2. Now we look, do we have like terms? Yes, we do. We've got just x's here, and if I've got 1 x and I take that x away, I'm left with 0 x's. So we're not going to write our x's down. If I've got -5 and I'm adding 2, I'm going to end up with -3. So when we simplify this expression, we are left simply with -3. And that means that no matter what value of x you chose, you could go and put any number in place of x here and here. And when you've typed it all into your calculator, you're always going to get just -3 for any value of x. Okay, let's look at this number 5. Number 5 is very, very, very dangerous. It is so tempting to look at this 2 minus 5 can be written as negative 3 times x minus 2. But if we did that, man, we've made a big mistake. And why are we not allowed to do that? Well, it all comes back to this symbol again. What does this symbol here represent? In fact, it originally represents subtraction. And what do we know is happening here? We have multiplication. So if you go and work out the answer of 2 subtract 5 and get negative 3, then we have violated the agreed upon order of operations. In order of operations, we have to do the multiplication before we do the subtraction. So I hope it's clear to you why we are not allowed to do that. So what are we meant to do? We realize that we can treat number 5 just like we did with number 3 and number 2. That we can go and multiply negative 5 times x and negative 5 times a negative 2. We are left with our 2. We are going to keep our 2. And then we're going to say negative 5 times positive x is negative 5x. Then we're going to say a negative 5 times a negative. We're going to get positive. And 5 times 2 is 10. Now that we have done the multiplication, we look. Can we add and subtract anything? Yes, we can. Here, I have like terms. So I'm going to write my x first, and I'm going to say I've got 2 plus 10 is positive 12. Okay, number 6. I want you to compare number 6 with our very first question, number 1. Man, that looks similar. X minus 5 in a bracket, x minus 2 in a bracket. But what's different between number 1 and number 6 is that in between this bracket now we have that minus symbol. Now we have subtraction. And so in fact what we're being asked to do here is to subtract x minus 2 from x minus 5. What are the purpose of the brackets around x minus 5? Well, there's no real purpose behind them. Nothing's happening in front of them here. And then we know with subtraction that we must go from left to right. So we realize that this first pair of brackets, x minus 5, you can think of it being multiplied by 1, but those brackets don't serve a purpose. However, the second pair of brackets, these blue brackets, that serves a purpose. And now we need to subtract an x, and then we are going to subtract negative 2, which, yes, you can immediately write as positive 2. Now we look again. Do I have like terms? Yes, I do. There are my x's, and if I have one x and I take that x away, I'm left with no more x's. Negative 5, adding 2, I'm left with negative 3 as an answer again. Notice that your answers to question 4 and question 6 are actually exactly the same, because in fact the questions are the same. If we remove these red brackets around number 6, we realize it's exactly the same question as question 4. Well done if you spotted that. Alright, the last couple. Question 7. Compare question 7 with question 6. I have brackets around x minus 5. Do these brackets serve a purpose? They definitely do. Because in these brackets we're multiplying x minus 5 by x. And then we are subtracting 2. I want you to read that to yourself. X minus 5 multiplied by x, and then we subtract 2. So, what are we going to do here? We're more used to x in front of the bracket, like that. Is this any different to writing x behind the bracket? Do those mean different things mathematically? Well, we know in maths that when we multiply, multiplication is commutative, which means the fancy way of saying the order that we multiply in doesn't matter. We're going to get the same answer if we change the order. That's true for addition as well, not true of multiplication or division. So, here we realize that this bracket of x minus 5 times x is the same as x times x minus 5. Where what would we do with that? We would distribute x to both terms. We're going to multiply both terms by x, and that's exactly what we're going to do here as well. So x times x is x squared, negative 5 times x is negative 5x, and then we've got minus 2. Now that we've done multiplication, we see, can we add or subtract anything? No, we can't. There's no like terms here. X squareds, x's, and constants. So that is my final answer. Alright, let's look at the last one here. Let's read this to ourselves. X, subtract 5x, and then minus 2. There's no brackets here. There's multiplication in the sense of we're multiplying x by negative 5. But we're not multiplying multiple terms by anything. This is to show you just how important brackets are. If there were brackets around this pair of terms, then we would do FOIL. But there's no brackets around those pair of terms. If there was just one pair of brackets around one pair of terms, then we would have to multiply both of those terms by negative 5. But there's no brackets. So in fact, there's no multiplication to do here. The only thing that we can do is to subtract the like terms. So if I've got 1x and I take 5x away, I'm left with negative 4x minus 2. And that's as simple as that one is. Spend some time going over these examples, noticing how important brackets are, where we put the brackets, and how the meaning changes. Notice how this minus symbol can mean different things. It can mean subtraction, or it can mean a negative in different places. Once you're happy that you understand all of these examples, go and practice it with the revision worksheet in the description below. Good luck.